All right, I think we're live here. Nice, yeah, we're connected. Welcome back to Buildnesday, everybody. My apologies for missing the streaming Factorio. That's not correct. I know that's not correct. I'll fix that right away. Every time I stream, it just completely overwrites the streaming settings, so not sure how we fix that. Always the struggles. Standard struggles here. And let's see, what are we posted for on YouTube? Details. No, this video is not made for kids. Made with Restream. Oh, Restream adds this weird header. Understood. We'll save that. Yeah, learning a lot about posting my live streams. Welcome, everybody. It's delightful to be back. I had a nice weekend away, but I was left very tired and also rejuvenated. I came back feeling really motivated to go swimming, and now I've been swimming 2 days in a row. Feeling much better. And my hips have been hurting a lot. Just all the sitting and laying down during COVID, I think. Kind of got a snap out of that. Delicious. Today we're going to continue our software brigade. We're going to continue writing the software that hopefully helps us to do some fun animations in OBS. Just as an overlay. Maybe allows us to collect stream elements from a recent time period and to animate them together in a fun, transitionary kind of energy. Just a fun, neat little project, something bite-sized. One of our main focuses is to leverage AI to help us define and build the software using recommendations that I hope are pretty solid in the industry. Nice. All right. Can I clear the chat here? Workspace. New chat. Okay. Okay, let me see if I can get my, is this good dev screen? Let's see, full screen, dark, nope, full screen, coding, coding. Okay. We don't need the terminal open or whatever. We were developing some specifications for our software. Let's see where we left off. We managed to get our extension set up. I also know that I'm able to now push code to our repository. And we've made an initial push on GitHub. Let's see. Let's go to that GitHub repository. Here we go. github.com/struggling-here. Nice. I fixed it all up to make it coherent with our name. It was some weird name before. I had to delete the account. So my apologies to anyone who got lost in the sauce there. I had to completely figure that out, so to speak. Struggling-here/stream companion. And that's our OBS web overlay system that we're kind of working on now, that we're defining. How far have we come in our description? So far, we've only published a .gitignore file, which contains very little. Just, it does not include a JPEG that's in my folder, and it's excluding these folders on purpose. So it feels a little bit personally revealing here, but we should get those files out of the Git tree. They don't belong there. And we've also got our README, which makes up this main page. It's a .md file here, Markdown. I'm not like a Markdown expert by any means, but with chat's help, we write all the standard documentation we need to using Markdown. So it's going to be a Python-based web application that you could run locally. Maybe we should highlight that in the opening. A Python-based web application. This system generates a web-based overlays on a local port. That can be integrated into OBS scenes through browser sources. Let's just say that real-time interactivity and customization for... It's about the animation sequences. Real-time interactivity, predefined animation sequences, and unique. They're kind of unique customizations, and unique customizations for streamers. There are kinds of customizations that I couldn't get out of the box in other places, maybe, or that I want to make personal and private, to have more control as an art form, especially. Nice. I'm glad we could clean that up. Okay. We're really trying to pound this out. Let's clean it up. We're taking care of business today. Look at this cool mug I got where you can actually see my chamomile tea inside the mug itself. I'm in there. In the tea. The Quark technologies at play here are a Python and Flask web server. And I guess we're going to be using Vue 3 as a single app architecture for the front end, where the base layer, Vue 3 with Vite and TypeScript, state management, because I'm requiring a lot of state management with a predefined package, Pina, and real-time updates using socket.io, the client library there. I also don't have any experience with GSAP or anime.jscript, JavaScript. But I believe that these modern packages will replace any functions I was going to turn to jQuery for. jQuery just isn't the tool. It's not the tool for the job. So let's just say this project is an evolution of an original form of the project that I had made many moons ago, 2017 or something, really. Maybe we'll write a short history about this project, but I don't have any code to share from that old project that I would want to make public yet. I could sanitize the code base and make it public, and then we could show its transition over time. For now, we use WebSocket for real-time communication with socket.io, just an SQLite database for persistent storage, keeps it simple and light, and OBS integration using the browser source integration, which is already included in OBS by default. Let's just include that. Leverage the included browser source. In OBS. To open the server's client app. It's not the client app. We're giving words the overlay to the server's overlay endpoint. There we go. Perfect. Key components here the web server, which is a Flask application. Now, I want to be critical of whether or not a Flask application is appropriate here. Let's open up AI and just have a little conversation. In 2025, what competing technology would replace Flask in this project? For real. Not, oh, hold on. Not an agent here. I think we're just asking. Let's ask. Good, send. Just asking. There may not be a good answer. That's okay. It's great if not. We would prefer to be using Flask by default. Fast API. In 2025, Fast API is the most common drop-in replacement for Flask in Python projects because it's ASGI native, async first, much faster, it has automatic open API docs, and it uses Pydantic for validation. Quick advantages: asynchronous performance, automatic open API and Swagger UI, type-driven request response validation with Pydantic, easy dependency injection and background tasks. I see. Replace Flask route decorators with Fast API/post and use async def handlers where appropriate. Convert your request response schemas to Pydantic models. Run with an ASGI server. Map the Flask extensions to equivalents. Flask socket.io goes to Python socket.io plus ASGI server, or use WebSocket Starlet components. Goodness gracious. Yeah, let's open up the agent here and say yes. Let's patch our current project. Look through each section carefully. And let's make changes to replace Flask. Like, is Flask too simple? Or is an ASGI server too complicated? Let's just ask some more questions here. How much more complicated is an ASGI server? One thing I like to ask as I'm developing software is about how much worse it's going to get if I pursue a specific technology. Evaluating whether or not a technology is going to be of use to me has a lot to do with the constraints that I'm working with. And the constraints at play here are me. I'm a constraint. Oh, it's popping PowerShell open here. I'm not sure why that is. That's so funny. Short answer, only a little. ASGI adds async concurrency and connection lifecycle concepts. But tooling, which is the Fast API Starlet plus Uvicorn and Hypercorn, makes it straightforward. Most added complexity comes from writing async code and deployment choices, not from the server itself. The key differences in what gets more complicated are the concurrency model, the asynchronous and await, and event loop versus synchronous threads and processes. You must think about non-blocking I/O. We have to think about non-blocking I/O and avoid blocking calls or run them in a thread pool. See, that's no problem. For us, a sequence of animations can be an asynchronous sequence of independent animations that occur with the right timing in between. So the key value for us is to remember that one call should not block another. Everything should be asynchronous. And the life cycles, the connection lifespans, background tasks, and graceful shutdown hooks are explicit in ASGI apps. I see. So that would keep our code really clean when it comes to the web app itself. It natively supports HTTP2, WebSocket, server-sent events, which is good for overlays, but it means that I manage different connection types. That's not great. Middleware and request handling, similar conceptually, but often asynchronous. Some WSGI middleware won't work. Deployment. Pick an ASGI server and configure worker/event loop. On Windows, use Uvicorn directly. Linux can use process managers. I know. Windows always needs help. The libraries. You need ASGI-compatible libraries or use synchronous wrappers. Socket.io and Twitch clients have ASGI asynchronous variants. Oh, interesting. Static files. Production static serving is still usually done by a reverse proxy or static file server. Uvicorn can still serve small sites for local use. Very good. Production static serving by a reverse proxy or static file server. Interesting. I mean, we could involve a second server here as in ASGI server if we need it. I just hope we don't need to add another piece of technology. This is meant to be something that a streamer could deploy on their own machine, and right away you would be leveraging the power of designing fun animations. That's the goal. It's going to pitch a migration checklist for me here to get away from Flask. What's it saying? Replace the Flask roots with the FastAPI Starler roots. Replace blocking libraries or call via run-in executor. Use ASGI-compatible socket libraries. Python Socket.io has ASGI support. And so ASGI, what exactly is ASGI? It's a kind of application specification that adds asynchronous concurrency and connection lifecycle concepts. And the tooling helps to make that straightforward. You just have to know how to use the tooling to achieve ASGI. But one of the key components of the ASGI protocol is that graceful shutdown hooks are explicit. And so you know that you can shut it down safely and you can just you can write better software. Seems like a good call. Like I was just hoping to use Flask and it could be sloppy, but you have to manage your own whole life cycle if you do it in Flask, right? The components that I render on the website, I have to decide where that code sits and injects. And I did in the original instance of this tool. I did have lifecycle management, but it was complicated as heck. And it's the reason why you couldn't just restart an animation halfway through, or if you did, it would have to replay the whole animation from scratch, or if you restarted the page, that it would replay every animation that had already happened, unless that code had been pulled out. You have to manage the life cycle for old animated components and pull those out after the animation happens, so that if you do get a refresh on the page, whatever is served is just what's fresh on the stack. So it's all this lifecycle management. Yeah, when is this extra complexity worth it? We should use ASGI if we need WebSockets, high concurrency with asynchronous I/O. I mean, Flask is good enough for high concurrency. Come on now. For a local OBS overlay, ASGI FastAPI is usually worth it because of WebSocket and async advantages. Yeah. Yeah. What is it about the WebSockets? Because Flask provides all of the tooling you need. Because an OBS overlay needs low latency bidirectional event-driven updates, ASGI and FastAPI gives practical advantages over synchronous WSGI Flask setup. Oh, I see. Native WebSocket support. ASGI and FastAPI with Starlet expose WebSocket endpoints directly, so there's no separate server or process needed. So the overlay browser source get instant pushes from the background software in Python. Whoa, I see. So it's true asynchronous I/O. The event loop handles many small I/O tasks, chat messages, Twitch events, file reads, socket broadcasts, efficiency without spawning threads for each connection. Yeah, wow. Lower latency, fewer context switches. I was just spawning threads. That's correct. Each one of my communications, That's why I wouldn't be able to have maybe hundreds or thousands of elements. Like there's a hard limit on what was achievable with Flask. Furthermore, a single process for HTTP and WebSocket and background tasks, easier deployment, fewer moving parts than mixing Flask, plus an extra WebSocket layer. Yeah. Cleaner lifecycle and background tasks because ASGI provides that explicit startup and shutdown hooks for connecting to Twitch, loading assets, or running background workers. Modern developer ergonomics, automatic open API, Pydantic validation for payloads, and async-friendly libraries make robust APIs simpler to write and test. When it might not be worth it, that's what I want to hear about. Very simple static overlay with occasional polling or a single admin UI. Flask is fine. See, that's kind of where I'm at. I'm like, this is going to be a pretty simple AI, but it's not going to be a static overlay, that's for sure. It's going to be something where things happen dynamically, and when that happens, I want there to be an instantaneous rendering. So yeah, I'm not 100% convinced that Flask is the answer. Or it's not worth it if I've got heavy blocking code that I can't easily make asynchronous or run in thread pools. Heavy blocking code. What do they mean by that? Yeah. What's an example of heavy blocking code that you cannot easily make async or run in thread pools? Yeah. Okay, hold on. Quick pee here. I'll be back in 30 seconds. Okay. Very good. Let's take a look. Yeah, the short answer to what's an example of heavy blocking code that I can't easily make asynchronous or run in thread pools? Because like imagine our animations. Our animations are going to be sequences of HTML and CSS that are brought on board into the web platform and that are injected into the browser locally. So they're highly independent most of the time. A sequence of animations goes off because it's expected to go off in a very templated way. Maybe one image is shown first, a certain amount of time is meant to pass, and then the next image is shown. These are highly asynchronous events. You're not waiting for some response back, in other words. Short answer, things that are effectively tied to native operating system or hardware contexts or single-threaded C code. Usually you have to isolate them in a separate process because neither... Dude, no. These are never... No, we never have blocking processes. Heavy blocking code that we can't easily make asynchronous or run in thread pools. So that's interesting. Flask is better if you've got heavy blocking code. Code needs to be asynchronous and it needs to fail out if it's not going to come back soon. Yeah. Just to clarify, what are the key features of code that is async? In short. Async def handler, literally defining it as asynchronous. Yes, certainly. Blocking. Non-block. Result equals await. AIO http.get. Concurrent tasks. Define. Main. Task 1 equals. .create task. .create task. Await asyncio.gather, and then you gather the results from both tasks, but they're running asynchronously. Interesting. That would be like our animations. We would have like animate each one of the components in a create task, and encoded in that would be the wait time from the start where it would appear. So effectively, it allows you to preload all the elements, and then they can appear, right? That would work. Uses coroutines, functions with the asynchronous definition. Operations that might block use await. It can run multiple operations concurrently. Relies on an event loop to schedule tasks. Yeah, it's so important that nothing is blocking. I've never had that problem in the first instance because the implementation was very simple. Again, you inject some HTML and a bit of CSS into the local endpoint, and that's very lightweight. That's just text. It's like a few bytes of text into a browser. So I didn't have any performance issues with Flask by a margin. Maybe because of the ingenious design I used, I'm not sure. I didn't think it was something special. I'm not using some heavy web framework, for example. It relies on an event loop to schedule tasks. It uses async-aware libraries. It handles errors with try and accept in an asynchronous concept. Do we see any try or accept blocks? No, I didn't see any try or accepts, but I get why it would suggest so. Most important, any function that calls an asynchronous function must itself be asynchronous, and it must use await. Await. Any function that calls an asynchronous function must itself be asynchronous. So it's just asynchronous all the way down once you make an asynchronous call. And you had to have been asynchronous from the start. So only asynchronous code works with asynchronous code. .gather, create task, await. Result equal request.get, await. What's AIO HTTP? Yeah, I guess that's standard. Async def handler, await, and then some IO operation. So you can wrap up your operations, even though they're maybe not asynchronous, into asynchronous definitions, but that are non-blocking. I mean, they might be blocking, and then, under the hood, and then we're all just waiting around. That's super helpful. That was super helpful. That was Claude Sonnet 3.5 giving those answers. Yes. Let's upgrade. Let's update our project. Did I paste this already? Yes, let's patch our current project. Look through each section carefully and let's make changes to replace Flask with the ASGI modern, ASGI compatible modern equivalent. It's an opportunity for us to learn more about these frameworks and the way that they interact with the browser. Browser is really fundamental to understand. Oh, we need to do the agent, excuse me. Agent. Let's go. Let's go, agent. Modern analyzing. Okay, first, Python ASGI web server, not Flask. Okay, you got it. Yeah, good call. Web server, fast API application. Got it. handles WebSocket connections, native WebSocket support for real-time updates, async asset serving, images, videos, sounds. Oh, that's amazing. Open API documented REST endpoints with Pydantic validation. Nice. Dependencies, backend, no longer Flask or Python Socket.io. We'll be using Python Socket.io's async WebSocket support, Uvicorn, and Fast API, as well as AIO files, the async file operations library. Looks like we're not going to be going with SQLite 3 anymore. Instead, we'll be using the asynchronous library, SQL Alchemy, and Pydantic for data validation, plus Fast API admin for the admin interface. That's just awesome. Flask admin was the admin interface foundation for Flask, so we've got great replacements. We'll take those. I mean, if this is real, right? Like, what percentage of this is fully hallucinated? I don't know. I don't know how much of this code is not going to make any sense. We're just defining a specification, right? It's all plain language here. Dependencies in the backend, no longer Flask and Socket, Python Socket.io, just the asynchronous part now of Python Socket.io with WebSocket support. And the asynchronous file operations library, AIO files. Okay, some performance considerations. Not just efficient WebSocket message handling, not media optimization and preloading strategies. It's async file operations, it's async WebSocket handling, it's concurrent request handling via ASGI event loop. Yeah, it's memory and resource management with background tasks. Everything is asynchronous. Fantastic. Nice. And our backend with SQL Alchemy is still consistent here, I guess. Flask, Fast API, great. Pew. Oh, wow. Wow, that's great. Okay, let's make a commitment there. Let's go to our source control with Control-Shift-G, and I'm going to use the AI message generator here to see what it gets us. Update README to reflect changes in backend framework and enhance project description. Yeah, away from Flask, right? Shift from Flask to Fast API in backend framework and enhance project description. Let's commit this and push it. Hopefully that just works. Did that work? I think that worked. I guess we could tell if we looked at Fast API. Yep, nice, nice. Update README to reflect shift from Flask to Fast API. Nice, nice work. Okay, good. So I don't have a lot of familiarity working in these in the GitHub interface specifically. I just use command line Git primarily, so I'm not super familiar with all the. It's very fancy. I very much like it. Yeah, and it says we committed just now, and 19 hours ago we committed our git ignore. Yeah, yesterday that was. I know I didn't hop on stream yesterday, but I was doing stream-related stuff, and I just couldn't get all my privacy settings set right. That was frustrating, so I took my time. And as I mentioned, I finally got back to the pool, so I took the time to come back from my trip and actually go to the pool and relax. So we are still using SQLite here for persistent storage. That's okay. Is that correct? SQLite? Asynchronous with SQLite. Yeah, SQL Alchemy and SQLite for the storage. So we are using the persistent storage, but there's a backend wrapper. Let's ask ChatGPT about this. What is SQL Alchemy? How does it relate to SQLite database? Oh, it's a generic library for connecting to databases, defining tables, writing queries, and for managing transactions. It's I see, it's an ORM. It's an object relational mapper and database toolkit, which has two main components: the core, the expression language in SQL, and the ORM, the object relational mapper, which allows you to define database tables as Python classes and to work with rows as though they're actually Python objects. Yeah, It's awesome. Object relational matter mapper, just awesome. So SQL Alchemy is going to make it really easy to work with data out of the database. And the relationship with SQLite is that it's going to allow us to access SQLite. It doesn't replace SQLite. It acts as an interface to it. So we can use SQL Alchemy to connect. I guess people call it SQL Alchemy. SQLite database. SQLite. I don't know. I said SQL for a long time growing up because I started using SQL when I was in grade 10. And I wasn't being taught by anyone. I was just teaching myself through books that I found in the library. But no one I knew had any knowledge to mentor me in database design or implementation. So all the database knowledge I have for the most part was originally formed just by hand, which is why I look a lot of things up and why I'm always interested to see how people learn to deal with databases on their own. I've always been using them at the command line. It's true. I mean, I love Mongo database because of the web interfaces. Holy cannoli. Mongo is so powerful as an unstructured, and being unstructured as a database, I find that so appealing. You know, you don't have to commit to table structure necessarily. And I know how that bites you in the butt in the end. As a physicist, I deeply appreciate how a good plan early allows you to scale incredible ideas over a long term, so you can build and build and build on something with a very solid, sound foundation. Here's an example of using SQL Alchemy with our SQLite database. Cool. Okay, feeling very good about that choice then. Would you like me to show you the fast API code structure that would implement these changes? Or shall we continue reviewing other sections of the README for modernization? Yeah, let's... Are there other outstanding components that need modernization? From the standpoint of an expert developer? An expert project manager. Keep in mind that this is a new project. So we have a unique opportunity to implement cleanly. Okay, I asked the agent there, but that's probably not the worst idea either. Current spec just mentions SQLite directly. We should modernize it to use SQL Alchemy async ORM with migrations. Consider SQLite for dev, but Postgres for production with better concurrent access. Are you joking? Like, we do not need a Postgres database. It's just easy to set up, right? Add Redis for caching or PubSub. I mean, it provides PubSub. Yeah. Can you do without that? Am I getting away from myself here? Because originally we were just going to use... Let's see here. Native ASGI WebSocket with socket IO sync support. Database. SQL Alchemy async ORM with migrations. Yeah, migrations are important. I agree with that. SQLite with Postgres production support. Ugh. Can't we just stick with one and do it? I don't want to have to learn both. SQLite is fine. SQLite is fine for the database layer. SQLite is literally so fine for the database layer. This is not, you know, the high concurrency. Like, let me just think about that. The concurrency is governed by whatever you can achieve in RAM, right? Through accessing SQLite, through SQL Alchemy. I don't see how adding Redis or caching for PubSub is going to be like worth it at all. Okay, here's media processing. Let's modernize the 2025 media stack. Cloud-aware asset management system, image optimization and async serving, WebM-video transcoding, audio normalization and web audio integration. I guess so. Background worker processes for media tasks. Yeah, I mean, and what media tasks do we do? I guess we need to serve videos sometimes, right? Yeah, and you need background worker processes for media tasks, that's for sure. I mean, before this, we had a media management section and there was only format validation and optimization in there. But now we've got background worker processes for the media tasks, S3 compatible object storage support. That's a lot. Really? S3 compatible object storage support? That's a lot. Really? Media queue system with a Redis backing, format validation, and WebAssembly optimization. Content delivery optimization, edge caching support, automatic format convert. Yeah, we need edge caching support. That's correct. Automatic format conversion, adaptive bitrate streaming. Adaptive bitrate streaming? What? That might be a lot. Are we expecting adaptive bitrate streaming? Governor? You want the sun and the moon and the stars and all the light in the sky, isn't it? I think we went more than ham. Let's expand it and then let's contract it. How about that? What about we expand this and then we contract it? Yeah, we'll use OR migrations, SQL alchemy, being specific about it. But I don't think we're going to migrate to Postgres. No, we're just going to keep this as in-house as possible, right? Yeah. We just don't need Redis for caching and for pub sub events. I don't know. How useful. Let's talk about the agent. Yeah. How useful is it to use Redis? This is an overlay for a single streamer. Yeah. At any given time, there's like one streamer using this overlay. Because I think it's going ham. I was overzealous with the Redis recommendation. For single streamers overlay, Redis would be over-engineering big time. Yeah. One instance runs locally, limited concurrent users, just the OBS and admin interface. No need for distributed caching. Events are local and sequential. Memory usage is highly predictable. In-memory queue for media alerts. SQLite is perfect. Exactly. ACID, single writer, local. What's ACID mean? That's so funny. Yeah, it was overzealous. It's a short way of describing why SQLite is well suited for certain use cases. Single writer, local. ACID compliant, which means it guarantees the four database properties for reliable transactions: atomicity, consistency, isolation, and durability. So ACID is an acronym for atomicity, consistency, isolation, and durability. I know, 10 out of 10, great. Single writer, only allows one writer at a time. Thank you. Even though you could read maybe in parallel. Nice. So I'm glad we backed it off. Yeah, we backed Chad off. It knows that SQLite's fine. Local file system caching is sufficient. Let's revise those sections to be more appropriate. Yeah, let's go. SQLite with proper async connection handling. In-memory caching for performance. Sure. Can I just say keep? Did it remember the old changes? I don't necessarily want those. Restore checkpoint. Okay, here we go. We're still using ORM migrations. We're not using Redis. We're just using SQLite for the database. That looks great. Nice. Okay. Media management, big improvement in the media management here. Cloud-aware asset management, image optimization, WebM-video transcoding, audio normalization, web audio integration. We didn't define any of these components originally, so this is really helpful for us. You know, we just weren't going to get to the media specification right away, but it's really important. So if we want this to be kind of like a fun image showing, video playing, quick clip having, quick clip having kind of fun stream component, then we need it to have full features for media, right? You can't not use JPEGs or whatever. And background tasks for media processing will allow us to serve videos in parallel without hangup, local file system with smart caching, in-memory queue system for alerts or media, format validation, and WebAssembly optimization. And some content delivery optimization, including edge caching support, automatic format conversion, and adaptive bitrate streaming. I don't know that we need adaptive bitrate streaming, but that might be helpful. Yeah, you don't always want to play the highest resolution all the time. Just, yeah, is adaptive bitrate. Sometimes you want to scale videos. Maybe we'll back that off later. Okay, we're updating the Python for native asynchronous features. Chromium 120 plus web browser support. Oh my gosh, we're modernizing our modernization section. That's so embarrassing, our system requirements. I don't know, maybe we don't want this to be too modern, but with a browser integrated IO, that seems correct, right? Chromium 120 plus. Yeah, like what about this? What if I just asked ChatGPT? Just give us a timeline of Python async support. .3, they introduced yield and from, enabling generator delegation, the foundation for coroutines. Then the async IO library first showed up in 2014. Async and await syntax in 2015. And then async IO.run was introduced in 2018. We got create task in 2019, toThread in 2020, 2021. Major speed ups to async IO now in 2022. The exception group. Okay, good. It's getting refined. So 3.11 plus is a big deal. 3.5 made async await part of the language, but 3.11 plus made it fast and robust enough for production-grade asynchronous apps with major performance boosts and structured concurrency improvements. It's awesome. Noted. So we're going to keep these changes as well. Docker support for easy deployment. Thank you. Whoa, thank you, thank you, thank you. Development setup, the local development, Poetry for dependency management. I guess we're using Poetry for dependency management, whatever that looks like. Pre-commit hooks for code quality, Rough for fast Python linting. Dude, I don't even know what this means. What is this? Tell me what these mean. Can I approve this stuff? What do these mean? You know? It shows a list of tools and practices used in local development for a Python project. Poetry is a modern tool for managing Python packages and dependencies. So it specifically provides a poetry.log file and pyproject.toml file. What do they call the toml files? Pre-commit hooks automatically run checks like linting or formatting before you commit code. Oh, I see. So when you use Poetry, it actually you're promising that you've run an algorithm on the code. And that prevents bad code from being committed, which you configure via the pre-commit config YAML file. And some example hooks that might run are like rough, the linter, or black, the formatter, MyPy, the type checker. Rough for fast Python linting. It's a very fast Python linter and code formatter, written in Rust. It enforces code style and catches errors early, like unused imports, bad syntax. PyTest is a popular testing framework for Python. Async support means you can test async def functions easily using PyTest async IO. For example, define PyTest dot test API, result equals await, assert, complicated. Okay, type checking with MyPy, strict. Yeah, so there's some features here, some complicated. Okay, hot reload with Uvicorn. Uvicorn is an ASGI server used for running fast API or Starlet apps. Hot reload automatically restarts when the server when you change your code. Great for local. Oh, that's awesome. Wow, that's awesome. That's obviously Uvicorn's huge for us. Obviously, Uvicorn's huge. Docker Compose for the local services. Useful for our local databases, yeah. Oh yes, Docker Compose. With sample config files, yeah. So I'm going to approve all of this. And let's take a look at the CI/CD pipeline. What's this? Let's take a look at all the choices here. What about these choices for a new project? Continuous integration, continuous deployment pipeline for automating the builds, testing, and deployments in a new software project. Yeah, okay. I mean, we don't really need continuous integration and continuous deployment. That's a little unnecessary, to be fair. So what were we recommending? GitHub Actions workflow, automated testing and type checking, container image builds, infrastructure as code, automated deployment to the cloud. No one promised that. That would be helpful, though. Perform regression testing. What kind of regression testing are we talking about? What kind of regression testing are we talking about? Automated testing and type checking. I'm okay with that. I think using MyPy and PyTest is good behavior so that we can learn the standards for making sure the code isn't totally crap. Code changes shouldn't break existing functionality. Should pass all the linting and typing rules. Keeps the main branches stable. Keeps our main branches stable, yeah. Let's see, the container image builds here. It'll build a Docker image. That's great. And they'll push to a container registry, maybe something public and everyone can get access to. The infrastructure as code in Terraform here. Let's see, Terraform manages cloud infrastructure, servers, databases, networking, etc. as version-controlled code. So, for example, you could provision AWS, Azure, or GCP resources automatically. And the benefits here are that it's reproducible infrastructure and easier collaboration and rollback. Yeah, you would be able to give someone a file that describes your hardware setup. It's not just a change across a dozen files. Yeah, sure. Sure. Yeah, as the code. Yeah, sure. And then you're like kind of saying it's my local server, or I want to use AWS for the back end. After successful builds and tests, the pipeline can deploy your app automatically. Examples: deploy the container to AWS ECS, Azure App Service, or Kubernetes. Update the infrastructure with Terraform. Reduces human error and accelerates release cycles. Now, again, this is not going to be an app that gets run all over God's green earth, right? These are excessive deployment choices for this project. I'm going to approve the type testing, but I'm not going to approve the continuous integration, continuous deployment pipeline. I'm just not. Multi-stage Docker builds. What does that mean? Hold on a second. Hold on. What about this? Hold the phone. Multi-stage Docker builds smaller, more secure Docker images so that I can build my app in one stage with all the dev tools and then copy only what's needed to a final lightweight image, for example. Smaller, faster, more secure images. Oh, I see. So a dev build, one stage with all the dev tools, and then copy only what's needed into final lightweight images. Oh, that's a great idea. Docker Compose for the orchestration. Manages multiple containers working together. I really like these setups. This is smart. Health checks and monitoring. Ensure that my containers are running and healthy. Docker can automatically restart the containers. Yeah, that's so good. Auto scaling config. Adjusts the number of running containers based on, okay, that's never needed. We never need this. We never need this stuff. The auto scaling, that's too much. That's too much. And zero downtime updates, that's not necessary. I'll take some of it, but I'm not going to take all of it. CDN for media delivery? Like, good heavens, dare I ask what's going on here? And these, chat? What do you think about these? Container orchestration, CDN for media delivery, object storage for assets, managed Redis and PostgreSQL, monitoring and observability, and cost optimization strategies. These are key components of a modern cloud infrastructure setup. Kubernetes and ACS Elastic Container Service manage the deployment, scaling, and health of containerized apps. Okay, I see. So we could have container orchestration just for the purpose of health management. Because it automatically restarts failed containers, handles rolling updates. I see. Open source, flexible, pretty complex. AWS managed, simpler, integrates with AWS Fargate. Like I'm not just going to have this roll out on Kubernetes. I don't have like a Kubernetes place where I can deploy it. And what part of the cloud infrastructure are we talking about here? We're talking about the container deployment, the cloud infrastructure in deployment. I don't think we're going to have cloud infrastructure for this. I'm going to say yes, but I don't think there's going to be any cloud infrastructure associated with this project. We're going to scale that way back. Multiple platform support? No. No. Well, maybe, yeah. Sheesh. Animation features, media rendering, chat integration, feature specification. Whoa. Yeah, we cut Redis, right? Yeah, good. Did it keep all of our changes? It's really hard to tell from looking at the editor if it's kept all the changes. Yeah, no, it didn't. It didn't. It didn't run through those at all. Let's try once more. Let's scale back the cloud infrastructure. This project is meant to run in a single instance every time for a single user. Yeah, let's keep it real simple. And we'll accept the changes. We'll accept them. It's hard to accept changes. I kind of you can accept them, but let's see here. Open the changes. Oh, open changes. I see. And I can go through the changes. And I could close changes, right? Toggle collapse unchanged regions. Split editor, open file, auto preview the side. Switch to next change. Close all, close saved. Okay, agent is going ham now. It's marking the audit to do as completed and marking the implementation of to do as in progress. Updating the core technologies now. Removing cloud deployment, heavy wording. Expected outcome, updated README, reflecting fast API plus local only architecture. There we go. Local only architecture. Thank you. Thank you. Oh boy, it's grinding its gears right now. Here, let that run for 30 seconds. I'm going to grab my tea. Oh. Oh. The AI decides to come running back. Okay, good. There's a lot of changes here. Whoa, it has a lot to say about Python. Replaced Flask references with Fast API and ASGI focused language. Updated the web server to describe Fast API features. Bumped system requirements to Python 3.11. Emphasized local storage and optional Docker. Replaced a backend dependency list with async local friendly packages. Expanded development setup and added a single instant deployment section. Okay. Yep. Real-time updates. Yep. Great. Great. The web server, Fast API application. Nice. We're keeping all of our multi-root system with the overlay, manage, and the interface for handling the REST API endpoints for external control. But now we've got some notes on managing asset serving and handling WebSockets. All inside the web server there. Yeah, that's great. System requirements are a little stricter. I don't think it's optional for Docker to be a isolated local deployment, but sure for now. Okay, we're cutting out the real-time chat monitoring. And Twitch integration. Like, is there going to be any Twitch integration then? Just dependencies. Like, this doesn't even make sense, right? Sure, cut it. Cut it. Twitch integration. Dependencies. The backend. Fast API. I don't see how this is Twitch integration. This has to be deleted. It's like it goes from system requirements. There's some confusing headings now, I would say. Web server, the core technologies, the web server. Wait, we have both now. Oh, we got some problems. We got some problems. This is going to be a confusing one. We only need Fast API, right? We don't need Flask at all. Let's move completely away from Flask. It searched for any words Flask. Yeah, okay, good. Pull that together for us. Tell us what we need to change here. Let's get a fresh description. Be nice if we could get an overhead view of all the headers collapsed. Can we collapse all? No, maybe not. Why does it always want to delete that this is a Python project? Doesn't have to be open about that, but yeah, let's just remove that piece there. That's right. Get rid of Flask. Creating a safer patch. Good. Yeah, our web server is completely going to be based in the Fast API, serving dynamic web content for OBS browser sources via ASGI. Serves a local management interface for component configuration and live operation. Okay, here's 4 more changes here. System requirements, upgrade those. Docker, keep it. Keep it. SQLite. Asynchronous SQLite. This all looks great. Okay, we kept it all. Let's commit that change here. Let's try again. Push from companion. These are very generic explanations. With move away from Flask and modernized tech stack. Won't be too specific, but commit that, push it. Let's take a look at our page here. So at the highest level, there's no project overview. There's just a technical architecture. It'd be nice if I gave a project overview, right? What happened to that project overview? This is just a list of technologies now. How could AI possibly understand what I'm even trying to talk about? How can it possibly understand at all? It's just getting away with itself as it hallucinated away my entire file. Let's add a project overview. Let's add a project overview, shall we? Oh my gosh. So bad. So cringe. This project creates a web overlay. Hosted locally. Which can be used as an OBS browser source to enhance the panache of your stream. That's the project overview, but let's add a section inside of project overview, which is design principles. Simplicity. Ease of use. And then power is the third thing. Power and fun. I think it's important to highlight those notes. If I ask AI to generate this, and design principles, oh yeah, specific-ish. Easy of use. Let's say ease of use here. And is features a thing? Feature specification. Yeah. The project also creates a web admin portal where the overlay can be managed. Creating a sequence of images animated across the screen. Having sounds playing and triggering the sequence. Triggering the sequence by a chat event or a button press in the admin panel. Let's call these use cases. Use cases. Let's just say that it is one or more of the following, possibly chained in sequence together. How are we doing lists elsewhere? Hyphens. Playing predefined sounds or triggering any sequence by a chat event or a button press in the admin panel. Nice. Let's get these use cases right after the design principles. I think the design principles are really important. Great. Just clarifying the project overview, design principles, use cases, trying to get the AI to better understand what we're trying to achieve here, actually. Fixing the capitalization on our tools. Let's go. Oh. Okay, let's commit and push that as well. Great. Okay, great. That probably is going to help the AI agent a ton with this. This project also creates a web admin portal where the overlay can be managed and controlled live. Design principles: simplicity, ease of use, power, and fun. Okay, those obviously have to be separated into bullet points. Simplicity, ease of use, power, and fun. They don't need to be on separate lines, honestly. Simplicity, ease of use, power, and fun. Yeah, I think a single line is fine. Use cases here. Okay. Technical architecture. Core technologies. Front end. Okay, so the core technologies. The back end is a fast API server. The front end is a single app architecture with real updates from socket.io. I guess that works. I guess that works. Is this going to work? and WebSocket database with SQLite OBS integration. Perfect. Web server has a multi-root system, including overlay, the management interface, and the API for external control. Okay, and then it just like fizzles out with Twitch integration and goes right into dependencies. We don't talk about Twitch integration. Yeah, let's just wipe that Twitch integration part out. I mean, we could revamp the Twitch integration features. Yeah, let's create a sample draft of the Twitch integration section. Based on the specification, this should not be totally clueless. Look at us. We're developing software. We're committing our code. Look at that. Multiple commits. Maybe that's not as obvious. Maybe if I move it over here. Yeah, you can see we got like 3 commits here. Commit skis. Very good. Yeah, for coding, should I be in a different location here? Oh, and my seems like my microphone died out. Let's just restart this. Nice, we're back. Okay, it's adding a brief Twitch integration section. No, I don't need an example implementation structure. Whoa. Yeah, we don't need all of that. We don't need all that. The features. Background task management. Chat commands. Yeah, let's build our own bot. It could be a bot, right? Customizable command prefixes, permission-based command access. Yeah, it's giving a full bot description here. Event integration, follow subscription notifications, bits and channel point redemptions, custom reward triggers. Yeah, it should have all of those, in my opinion. Like, we wanted that the whole time. State management with in-memory event queue, WebSocket client tracking, rate limiting, and cooldowns. Yeah, thank you. Yeah. Yeah, a lot of this is important. Secure token storage using environment variables, channel point redemption validation, configurable command cooldowns, example usage. Yikes, and it's giving error handling, performance notes. Okay, same thing. undo all the edits. The code is ready to extend with, yeah, this is too much. It's too much. Scale it back. Yeah, let's scale back on the amount of example. Let's scale back. Let's not talk about the examples. Yeah. Let's not insert examples here of the implementation. Since this is the software specification document. I know it looks like a README, but they might as well be the same thing. The software specification should be very similar to README. Right? In a modern era, people are only going to read the README of your front page anyway. And this way, there's no question about what my piece of software is. Okay, here we go. Chat integration, but we're keeping it simple. Event handling, authentication and security, and performance consideration. Done. That's what I'm talking about. Yeah, that's what I'm talking about. Let's make that commitment as well. Nice. This is kind of confusing. The numbering on Twitch integration is 2 and on web server is 1. But then there's like a system requirements section in web server. Core technologies, system requirements. How are those meant to be shown? Core technologies. And this technical architecture we never talk about. Oh, yes, I see. Technical architecture under which falls the core technologies. And then web server is one of the core technologies. I see. Backend, front-end, WebSocket database, OBS integration. And then it goes into greater detail. It's like number 1, the web server. But that is a subset of core technologies. And then it should be like, what? Where's system requirements? Could we rearrange? Is there a better arrangement of information in the core technologies section? It's a little confusing. Yes, let's reorganize it to be logically grouped and eliminate the redundancy. Let's take a look at what it recommends. So it's going to go backend stack. Data storage real time. Front-end architecture. OBS integration. And then it's not going to touch this next section. It's like web server, system requirements, Twitch integration. So it didn't really understand it. I liked the original. No, I liked the original. I meant something different. Because it's... Because there's the web server, front end, back end, WebSocket, database, OBS integration. And the web server, there are 3 separate endpoints. So there's web server, and then system requirements. So can I just delete the web server number 1? Can I just delete the numbering on web server? Web server, system requirements, Twitch integration, right? It's not optional. Docker for isolated local deployment. Yeah, for development or for deployment, you only need Docker. And then there's system requirements for development, of course. Sorry, we should turn this into sections. For deployment, for development, local storage for, oh yeah, deployment and development. Yes, network access for Twitch, local storage. Twitch integration. And this is all, yeah, this is web server, this is system requirements. So we'll do Twitch integration. And then we'll do system requirements. Yeah, there we go. Okay, how does that look? We just rearrange some sections here. To improve clarity. The technical architecture was just confusing. Like, now we fixed it up. It's core technologies, design principles, use cases, all underneath project overview. That's great. Technical architecture, core technologies, the web server. So yeah, it's just kind of a bullet point list first, and then it's more in depth. It's the web server, it's the Twitch integration. Does that belong under technical architecture? Chat integration with event handling and authentication and security. But it's not core technologies, right? That's what's confusing. Is this is slop now, right? Okay, let's update the Twitch integration to conform with its position as a bullet, or it's a subsection of core technologies. Does it understand what we're talking about? Please make this a section in core technologies. Good point. It's not supposed to be like a rather than feature details, which can go in the feature specification section, which we should put in the feature specification section. Good. It didn't find anything for hashtag 2.twitch integration, but that's not what you would want to look for here. Okay, it's cutting all the chat integration, and it's adding asynchronous Twitch client, WebSocket-based chat connection, PubSub for channel events, local architecture, core components, message pipeline, reward triggers, alert system, integration points. That's great. That's great. Keep that. Let's now add the features. Add the Twitch integration features. We'll say we'll add the chat integration features. Let's also move away from calling it Twitch integration and calling it chat integration. Accepting chat from YouTube, Twitch, Facebook gaming, I guess, like, or other streaming platforms. YouTube, Twitch, Discord. Let's start with Discord. And other chat sources. Okay, we're going to expand the feature list here with Twitch chat stuff. What does it think? Great idea. Oh, it's deleting what we had before in this chat, in this Twitch integration section. No. I don't want to delete what we have in Twitch integration. Multi-platform support. Oh, it's updating Twitch to multi-platform. Yeah, there we go. Unified message queue, cross-platform user identity, event architecture, integration layer. Looks good. That looks good. Yeah, this one looks really good. And now chat integration doesn't talk about user badge new out rendering and message filtering. It talks about platform support, chat display, command system, moderation, and event handling. Cross-platform user tracking, unified moderation actions, platform-specific timeout/ban support. I don't know how I'll have cross-platform user tracking. Oh, well, we'll allow it. That looks great. Yes, for chat platform connections, ding. There we go. Okay, let's make that commitment as well. That's a pretty big deal. Multi-platform commitment. Ba-boom. Yeah, pretty big refactoring there. 47 substitutions, nice. There we go. We're not talking about Twitch integration. We're talking about chat platform integration. And hopefully this makes sense now. We've got a web server, and another big component is the chat platform integration. So the web server is what's serving locally, and that's like getting your videos and things. And maybe we want a media generation tool that takes your stream and captures components, but I think that's a little beyond this tool, to be honest. We want to just allow ourselves to predefine things, but if I build tools that generate the images, I'll be able to ask this tool to pick up on those images, depending on what they are. Yeah. Yeah, we always want to be able to manage all the assets coming through this. That's why I immediately think about capturing assets using this tool, because we've got a huge amount of overhead already just managing assets, but capturing is a small additional cost. And then for system requirements, we've got deployment and development, And development will also require. Oh, actually, modern web browser, yeah. Yeah, we just should cut Python dependency. That's not needed, is the truth. System requirements. Management interface system requirements. Oh, and then technical requirements. Yeah, I see. We kind of want to leave system requirements the way it is because it refers to the system requirements for maintaining the software, not for deployment necessary. These are technical requirements. So I'm going to leave that. Okay, what's this animation system deployment? Keep backups of data and media. Avoid complex orchestration for this use case. Yeah, there's no other type of deployment here. Just single instance. Development also requires, yeah. Good, and development also requires Python. This is not that complicated a specification now. Let's just say refining. Clarifying finer details across the specification. There we go. Worse than AI, even. My commit messages, worse than AI, arguably. Because now you're looking at a pretty simple document. It's technical requirements. Stream companion. Let's see. Project overview. Technical architecture. System requirements. Dependencies. Yeah, the system requirements are different than dependencies a little bit. A lot of dependencies. There's dependencies in the back end, and then there's no dependencies in the front end. What's that all about? And then animation system just kind of dies out. Here. So maybe we should refine the dependency section. Like, we don't have to refine into back end, front end. It's only a back end. There's no like front end dependencies. You just have to have a modern browser. These are the system requirements. And I'm just going to say the back end. I'm going to delete the word dependencies because we said system requirement already. Yeah, and we'll just go straight into backend. And I'm just going to say Python. It's deployment and development. And then there's full backend dependencies. Yep. I don't know what this quick local run is exactly. And then animation system is just kind of dead on arrival here. Kind of funny. Okay, feature specifications, chat integration, media rendering, animation features, custom animation sequences, color effects, transition timings, image transforms, text transformations. Easing functions, custom animation sequences, yeah. It has strong integration, strongly integrated with media management features. And where are the media management features? This is all just chat integration, media rendering, dynamic overlay system. Event parameters, asset management. Good, template lifecycle. View component types, template manifest system, parameter types. In the template manifest system, there's JSON schema definitions and then also parameter types. So the template manifest system is part of this dynamic overlay system. I guess that works. I don't know how view works, so I respect whatever that looks like. And the template lifecycle, create and edit in the management. That's probably correct, right? Create and edit in the management UI, export the complete manifest JSON, import load or live preview or instant deployment. And then a management interface. Perfect. And here's that management interface. Okay, yeah, that looks great. Save that. And what else do we have here that makes no sense? We had animation system, made no sense, but now we've got feature specification, including chat integration, media rendering, animation features, the dynamic overlay system. Maybe the dynamic overlay system is too specific, but I think we wanted that much. The management interface, media library browser, file upload system, yeah. We do want components like chat integration and effect sequences. Yes, we do. Yes, we do. System requirements, dependencies, backend, front-end management interface, front-end overlay system. So this set of dependencies, this is another list of dependencies, right? Dependencies. Backend. This is backend with development setup under it. And this is dependencies with backend with front-end management services and a front-end overlay system under it. What section is this under? Technical requirements. And we already had system requirements, right? Dependencies, system requirements. It's bad. It's slop. It's a touch slop. And then performance considerations is kind of like another section there. Yeah, dependencies, performance considerations. But performance considerations is a subsection here of technical requirements. And then safety considerations is its own setup. Development setup, no one knows that. Deployment, no one talked about that. Oh God, this is all out of order, right? So we do technical architecture, and then we do development setup for some reason. So we need to get development setup out of here at the top. Yeah, let's just get that out of here and leave feature specification. System requirements, feature specifications. Dependencies. Yeah. There we go. And then development setup. How about that? Can we view this? There's a way to view. Render? Not sure. There's a way to take a look at. It's one of these extensions here. Markdown. I'm not sure which one. Looks like I didn't install the. It's not at the top anyway. Yeah, the only way I know to render Markdown. What's this? Split editor right? No. Uh-oh. How about rendering it? How about open preview? There we go. There we go. Can I edit here? No. Security considerations. Development setup. Local development for single instance. Quick local run. Deployment. Single instance. Development setup. Now I can delete this. And deployment. Now I can delete this. There we go. Future enhancements? I don't know about that. Interactive viewer games? Actually, I love that. Stream statistics overlay? Love that. Custom widget development API? I love that. We should just ask for that in the default, right? We should be like, it can do this, and then it can define this path. Is that way too much to integrate? It's asking for way, way, way too much. Um, I want to keep our implementation simple and straightforward, and I don't want to bite off more than we can chew just because it's a great idea. Okay, nice. We got README simplified, and we fixed redundant sections, actually. So let's just take a look at our commitments. What does AI think we did? Streamline development, set up instructions, enhance deployment guidelines, and clarify feature specifications. Correct. Great. No dead sections at the end. Just deployment is there and development setup is there. Security considerations are here. Technical requirements are here. Feature specification is one of the most important things. I think animation features should be before chat integration. Media queue system. There we go. Fast API admin, optional admin UI. Video file handling, sound effect library, media queue system. See, this kind of stuff kind of doesn't make sense in system requirements. And the backend makes sense until you get to here, this optional fast API admin. I'm okay with it for now, although that's a little shaky. That's quite a few commits it took to get through this. Can we take a look at all the commits? Issues, actions, insights. Yeah, here's the commits. Refactor README, clarify finer details, refactor README to streamline development system process. Yeah. It loves refactor as a description for what we're doing here. That's amazing. Okay, and again, with the help of AI now, we have significantly reshaped the project from what it originally was. We've clarified some design principles, but we've shifted away from Flask even and towards Fast API. Let's just make sure we're not making any mistakes here. As an expert developer, what pitfalls for Fast API if we're migrating, if we're starting a new project instead of using Flask? Async complexity is often misunderstood. The Fast API async model is powerful, but it's not magic. Mixing asynchronous code with synchronous, blocking database drivers, file I/O, or external API calls can silently degrade performance. You must use asynchronous compatible libraries, or you lose the asynchronous benefit. Debugging asynchronous issues, event loops, await misuse, can frustrate teams who are used to Flask's simple synchronous model. Yeah, I like it. I mean, if it's going to work asynchronously right out of the box, that was the whole goal. We just need to design code that's asynchronous. And good for us. We should be able to. There's a limited mature ecosystem here versus Flask. It's old. Flask is older, broader. Yeah, whatever. We're doing something special. Use modern asynchronous compatible tools. Oh, Celery is still synchronous. Steeper learning curve for typing and Pydantic. Fast API relies heavily on Pydantic models and type hints for validation and serialization. That seems correct. You want to be able to encode serializing a really tight way. I'm on board for all the features here. It's great long term, but it can overwhelm teams that are new to type heavy Python or dynamic schema validation. Yeah, I am new to type heavy Python. Migrations between Pydantic version 1 to version 2 also cause significant breaking changes, so keep that in mind for your long term maintenance. Yikes. Love breaking changes. CPU-bound tasks like image processing, machine learning inference won't benefit from fast API's concurrency. You'll need task queues or work processes for heavy workloads. Dependency injection is powerful but easy to misuse. Fast API's depend system looks simple but can become unmanageable if used everywhere without structure. Circular imports or complex dependency chains can appear quickly. Oof, yikes. I want to get into a complex dependency chain. Use a clear layered architecture. Routers for endpoints, services for business logic, repositories for database logic, and keep depends only at the router layer. Ooh, really? Interesting. That's interesting. Yeah, I wouldn't want circular imports. That would really break our flow. Operational overhead with asynchronous servers. Flask typically runs under G-Unicorn plus WSGI, simple and stable. Fast API needs Uvicorn or Hypercorn, which means tuning the worker's lifespan events and async signals properly. I don't know if we're going to do any tuning. It just will work, is my guess, but it's a very low overhead. The mitigation here is to use G-Unicorn with Uvicorn workers for production. What? Flask may actually be leaner because Fast API is highly opinionated and needs a lot of scaffolding. Use Fast API when you need asynchronous I/O, many concurrent requests, or you want automatic API docs. Otherwise, Flask's simplicity still wins for small tools. Yes, it's less micro than it looks. When Fast API is absolutely worth it, you're building a modern API with asynchronous endpoints or WebSockets. I think we should just give it a whirl. We'll go with Fast API. I think it's okay to move away from Flask. Flask had so many complexities in setup anyway. With the reverse cores proxy or whatever. I don't know if anyone's here has had experience setting up Flask or using Flask in Python, but there's a lot of hangups that come out of the box that folks may not know. Wow, this is a huge design specification. Outstanding. Huge, huge, huge. How many words is this thing? It's I don't know if I can get document statistics or not. Maybe I can get them here. Number of lines changed, but not the total number of lines. Yeah, the size of the files doesn't seem to be the most important thing. The word count is not really well documented here. Cool. Okay, that's another great few steps towards our development goals here today. Let's take our brains off of high energy mode and just take a moment to relax them. Thank you for joining me. I've got to go to work now, so I've got to run off. But thank you for joining me. I'm apologizing again for getting started late, but the intention here is to stick with our original schedule. I'm going to come back on Friday for our Factory Fridays here, and I hope to play Factorio, pick up where we left off in Factorio. But maybe it will look like playing a little bit of Satisfactory. Hard to say. We'll see. Come out and join me for Friday at 9 a.m. Pacific. Until then, keep on struggling with your own projects. And yeah, if you spend enough time, eventually you'll struggle hard enough to produce something. Our design specification is pretty far. Maybe it'll actually crack code next time we work on this.